The deep learning market is estimated to be valued at $3.18 billion in 2018 and is expected to reach $18.16 billion by 2023. Verified Market Research also valued machine learning as a service market at $2.48 billion in 2020 and is projected to reach $38.81 billion by 2028. Are they not the same thing? No. And for today's video, we will share the similarities and differences. Here is deep learning versus machine learning. Let us get into it. Machine learning is when computers learn from data. It is the intersection of computer science and statistics. Here, algorithms perform specific tasks without being given explicit instructions. Instead, they recognize patterns in the data and use them to make predictions for the new data. A simple example is when Amazon recommends certain products to you. Their recommendation engine analyzes the data of people with a similar buying pattern to yours to predict which products you are likely to purchase when shown. In general, algorithms can be either supervised or unsupervised. Machine learning enhances many industries, including robotics, healthcare, and finance, with algorithms that make work easier for humans. Similarly, some industries benefit immensely from the developments in deep learning. Later, we will tell you how EV makers like Tesla are using deep learning to identify objects on the street to make the concept of autonomous driving a reality. Smart bulbs and Alexa also use deep learning to make our homes smarter. We will present more on these shortly. Deep learning algorithms are a mathematically sophisticated and complex evolution of machine learning algorithms. As such, deep learning describes algorithms that analyze data with a logic structure that is strikingly similar to the human brain. Moreover, the application of deep learning also happens through supervised and unsupervised learning. To illustrate, deep learning applications use a layered structure of algorithms called an artificial neural network, ANN. The ANN is directly inspired and designed to be biologically identical to the human brain's neural network. Hence, the basics of deep learning are far more capable than that of standard machine learning. Today, deep learning is the ultimate choice for many industries. For instance, deep learning detects objects in automated driving, such as signs and pedestrians. In addition, the military uses deep learning to identify objects from satellites to determine safe or unsafe zones for troops. Of course, the smart home project is intrinsically a deep learning zone. Home assistance devices and applications perfect one's preferences and voice command with the help of deep learning. Indeed, machine learning means computers learn from data using algorithms to perform a task without programming. Deep learning means computers learn from a complex structure of algorithms modeled on the human brain. This processes data such as documents, images, and text. As we have explored the individual categories of deep learning and machine learning, we will state three distinct differences to help you separate the two methods of teaching computers to predict accurately. Things like human interference, data volume, and structure complexity separate the two methods. But first, let us tell you how the two overlap. Meanwhile, if you took a deep learning tutorial, you will find that it is a subset of machine learning, while machine learning is a subset of artificial intelligence. And as we know, artificial intelligence is no match for natural stupidity. To emphasize, deep learning is machine learning. Further, deep learning algorithms are machine learning algorithms. Therefore, the ANN algorithm structure, the lower need for human intervention, and the larger data requirements make deep learning advanced and probably a better version of machine learning. Still, we will look at the differences that set them apart. Here is deep learning versus machine learning. First, while standard machine learning algorithms have a simple structure like linear regression and decision trees, deep learning employs a more complex structure based on an artificial neural network. As Tim Green said, the human brain is estimated to have about 100 billion nerve cells, 2 million miles of axons, and 1 million billion synapses, making it the most complex structure, natural or artificial, on Earth. The complexity of the human brain and its intertwined nature are all replicated. Do you think we can fully model the human brain and have computers thinking better or as much as humans? Kindly share your thoughts with us in the comments below. Secondly, deep learning algorithms require less human intervention. Suppose a Tesla is learning to identify stop signs. In machine learning, an engineer will input many images to help the machine figure out what stop signs are and how to identify when they are not. However, in deep learning, the machine extracts the data itself and learns from its errors until it perfects what a stop sign is. Before we go into the final one, here is your note to subscribe to our channel for more on machine learning and the future of tech. Finally, deep learning requires more data to function correctly than a traditional machine learning algorithm. While machine learning works with 1,000 data points, deep learning starts with millions. Due to the complex multi-layer structure, deep learning systems require a large dataset to make high-quality predictions. To summarize, machine learning is the intersection of computer science and statistics, where computers learn without being explicitly programmed. There are two broad categories of solving machine learning problems. They are supervised and unsupervised learning. On the other hand, deep learning is a specialized subset of machine learning. Deep learning relies on an artificial neural network, a layered structure of algorithms. Although deep learning requires vast data, it does not need much human intervention to function correctly. For the large training datasets, transfer learning is an option. If you want to learn more about deep learning, here is a video for you: Top 7 Deep Learning Applications and How It Works.